Hey everybody. So we're looking at 18.2, 18.3 lesson today. And what we're going to be looking at is the volume of two more solids. And those two solids are a pyramid and a cone. All right. You'll see the formula to these is very similar to the formula that we used in the last lesson when we were finding the volume of prisms and cylinders. All right. So all I need you to do on this is get the title, and then we'll explain where the formula for these two shapes comes from. Okay, so let's go ahead and read this together. It says, recall that the volume of a prism is capital B times capital H, where B is the area of a base and H is the height. Okay, we remember that from the last lesson. It says, in the figure at the right, you can see that the volume of the pyramid must be less than the volume of a prism. Let's just stop there. If you guys take a look, they have a pyramid inside of this prism, and it's kind of obvious that the volume of that pyramid would be less than this prism. Okay, so what does that mean? Well, here's the thing it says. It says, notice that it has the same base area and height. Okay, the base of this pyramid is the same as the base of the prism. Okay, the height of this pyramid would be the same as the height of the prism. Okay, so ultimately what this all comes down to is this last thing. It says the volume of a pyramid is 1/3 the volume of a prism. Okay, and that leads into our formula. Okay, here it is. V equals 1/3 capital B times capital H. All right, so go ahead, take a minute to copy this formula, get the drawings of this pyramid and this cone, and then we'll get into it. Okay, so big thing when it comes to this formula, this capital B is still our focus, because what we plug in for capital B is not just a single number, it is a formula to find the area of whatever the base happens to be. If our base is a square, we plug in the formula for the area of a square. If our base is a circle, we plug in the formula for the area of a circle. Okay, this is always changing. All right, the height of the pyramid and the cone is pretty simple. It's always at a 90-degree angle to the base. Normally they'll show it going inside of the shape, though it's possible for the height to be shown outside the shape. Okay, one other thing you might notice is there's this blue line going across the side here. This is actually called the slant height. We're gonna kind of see that today, but it's just something I want you to take notice of. This is considered the slant height, and this is considered the height. In the future, knowing the difference between those two is going to be, something we need to know. Okay, but yeah, this is our formula we're going to use on every problem. So let's jump into it. Okay, so go ahead and copy this problem here. By the way, when you go to draw these things, it's easiest just to start with the base. So, we can, oops. So if you go to draw this on your own, let me just give you a little drawing lesson. All right, I would probably draw that triangular base first, and then I would put a point above it. And then basically from the vertices of this triangle, I'm going to draw them all the way up to that line, and I will have, my solid, my 3D drawing. Okay, so that's the way I recommend drawing it. Just do your best on it. Don't worry if it doesn't look perfect. Okay, so yeah, go ahead and get this. Okay, so it's a pyramid. We're asked to find the volume. Let's go ahead and write out our formula. Volume equals 1/3 area of the base times the height of the pyramid. Okay, so just like our last lesson, the most important thing and the very first step is to get what formula we need to plug in for the area of the base. Well, if you guys take a look at this one, the base of our triangle is pretty obvious. By the way, there's only a single base on a pyramid and a cone, and it's usually pretty obvious where it is. All right, and yeah, we can see it's this triangular base right here. All right, so now that we know that it's a triangle, we need to plug in the formula for the area of a triangle. Hopefully you've memorized this by now. To find the area of a triangle, it's 1/2 base times height. Okay, and then times the height of the entire pyramid. Right, so really this is our formula we're going to be using. Let's go ahead and plug in our numbers. Okay, so I got 1/3 times 1/2 base times height. The base of the triangle I would probably consider to be 4, and the height would be 6. Remember, it's always at a 90-degree angle. So 1/2 times 4 times 6. And then times the height of the entire pyramid, we can see right here that they're telling us it's 9, times 9. Okay, and then from here, it's just a matter of plugging this into our calculator. By the way, this is all multiplication. We don't necessarily need the parentheses, though you could put them if you wanted. I'm just going to go ahead and multiply it all together. So 1/3 times 1/2 times 4 times 6 times 9. Let's see if I can remember that. Okay, so at our calculator, we have 1/3. Remember, after you write that, click the cursor to make sure it's right next to it. So times and then 1/2. Again, click the cursor so it gets out of the denominator. Okay, times, and again, I forgot my numbers. 4 times 6 times 9. So times 4 times 6 times 9. And it looks like we're ultimately getting 36. Okay, so there it is. Volume equals 36. Just like before, volume is in units cubed, and our units are meters. So 36 meters cubed. All right, just a reminder, volume, it's all about the inside of the solid. You can think of it as how much water would fill up this solid. Well, 36 meters or cubic meters of water would fit inside of it. Okay, cool. So yeah, that's a pyramid with a triangular base. Let's look at another. Actually, I'm gonna have you guys go ahead and try one, a pyramid. You guys can see the base of this one. It's not a triangle. It looks like it's a rectangle. All right, so go ahead and start with the big formula. Volume equals 1/3 area of the base times height. And then from here, first things first is getting that formula. Sorry, 1/3. But yeah, getting that formula for the area of the base. I'm going to leave this to you. How do you find the area of a rectangle? That's what you're going to plug in here, and then times, capital H, the height of the whole thing. Okay, so go ahead, try this out on your own. Okay, so if you guys remember, to find the area of a rectangle, really simple, just base times height. All right, so there's my formula. Now we can plug in the numbers. Make sure don't plug in the numbers before you actually get everything written out. Okay, so we got 1/3 times the base and the height of my rectangular base. All right, well here's the base of it. All right, and the base of the rectangle I would consider 2.5 and the height 1.5. So I got 2.5 times 1.5. Okay, and then times the height of the entire pyramid, we can see right here, pretty obviously, so 1.7. All right, so yeah, there is our formula. Let's go ahead and plug it in. 1/3, 2.5 times 1.5 times 1.7. So I'm gonna delete this. All right, so 1/3, move my cursor, times 2.5 times 1.5 times 1.7. Okay, and I'm getting 2.125. All right, on these, we'll normally, unless they say otherwise, we'll round to one decimal place. So we're going to say 2.1. Okay, so volume equals 2.1 units cubed. Okay, so let's keep moving. So from here, we're going to look at finding the volume of a cone. Yeah, so go ahead and copy this. Actually, I thought I wanted to do a different one first. Yeah, actually, I want to start on this one right here. All right, so this is our next example. All right, go ahead and copy this cone, and then we'll do this one together. Okay, so, it's a cone, so we know to find the volume, it's just the same formula, 1/3 area of the base times the height of the cone. All right, first things first is plugging in the formula for the area of the base of a cone. A cone is defined by having a circular base. That's what makes it a cone. Okay, so yeah, circular base, what is the formula for finding the area of a circle? Pi r squared. Okay, memorize it. Okay, and then times capital H, the height of the whole cone. Okay, from here, just to take notice, we need the radius, which we are given, and we need the height of our cone, which it's a little weird. It's kind of slanted, but it's still at a 90-degree angle. So we do know that, yeah, that is the height. All right, so let's try it out. Volume equals 1/3 times pi. Our radius is 2.2 squared times the height of the whole cone, 4.5. And all we need to do now is plug this into our calculator. All right, so let's go ahead and do it. All right, so 1/3, move my cursor, times pi 2.2 squared Oops. So yeah, I went back. Just make sure your cursor's in the right spot. So 2.2 squared, there's my square bunch, by the way. And then again, times the height of the whole thing, which was a 4.5. That's weird, it disappeared. You see that? Huh, times 2.2. That's really strange. Something weird happened here with me flipping back and forth. I'm gonna delete this whole thing and try it again real quick. So 1/3 times pi 2.2 squared times 4.5. So yeah, that was a little strange. I don't know why that disappeared. But I'm getting 22.80, so we'll say 22.8. All right, and our units are centimeters, so centimeters cubed. Okay, so typically the height of your cone will be coming from the center of it like that. But since this one was kind of slanted, it was a little different than your typical one. But again, height is always at that 90-degree angle. Let's try one more of these cone problems. Let's take a look at this one. Go ahead and copy it, and you'll see it's a little different than the others. Okay, so first things first, volume equals 1/3 area of the base times height. All right, again, our base is a circle, so we need to plug in the formula for the area of a circle, which is pi r squared times height. All right, so here's where we kind of run into an issue here. We have the radius of our circle, it's 5, that's nice. The height of our cone, though, is this line right here. And we are not given the height of our cone. We're actually given this right here, which, if you guys recall, is called the slant height, which we do not use when we're finding volume. Okay, so we need to find the height of this cone before we can plug in our numbers. Okay, well, how do we do that? Well, if you guys notice, this right here is a right triangle. And we have two sides of the right triangle, and we're looking for this missing side we can call x. All right, how do we find the missing side of a right triangle where we know the two other sides? The Pythagorean theorem. All right, and it never goes away. So Pythagorean theorem off to the side, c squared equals a squared. Oh, I'm getting sloppy here. A squared plus b squared. Okay, plugging in our numbers. C is always the hypotenuse opposite that right angle, so we have to plug in 8. A and B are the other two sides. I'm going to make 5a, and I'm going to make xb. Okay, so we're going to go ahead and solve this thing for x, right? So yeah. Okay, so let's go ahead and solve for that missing side length. So 8 squared is 64, 5 squared is 25, plus x squared. Okay, and then subtracting 25 from both sides. So I'm just going to do this in my calculator. Looks like I'm getting 39. Okay, equals x squared. Okay, and then solving for x, undoing squaring with square rooting, right? Okay, and then I'm just going to type this into my calculator. Square root of 39 is giving me a 6.24. All right, which I'm going to round to a 6.2. All right, so there it is. I figured out my height. It is 6.2. Technically, we're talking about meters. All right, so that is my height. Now I can use that to plug in my numbers here. So volume equals 1/3 times pi r squared. We just figured out, or never mind, r is 5. And the height is what we just figured out, 6.2. All right, so 1/3 times pi 5 squared times 6.2. All right, so 1/3 times pi 5 squared times 6.2. Why does that look so weird? There's something about me going back and forth that's giving me wrong answers, I think. Let's see. There we go. Finally did it. Okay, so I'm getting 162.31, so 162.3. All right, and we're talking about units squared, so units cubed, excuse me, so meters cubed. Okay, so last thing, I'm gonna have you guys try a problem out a lot like this. All right, I'm going to go ahead and have you find the volume of this cone. I'm going to get you started on this, and then I'll let you go from there. So, go ahead and copy this, and then we'll get it started together. Okay, so volume equals 1/3 area of base times height. All right, here's, the big thing. The base of a cone is a circle, so we're going to plug in the formula for the area of a circle, which is pi r squared times height. All right, here's the big thing on this problem. We are given the height of our cone. All right, it is 20. All right, so that's nice. We do know what the height is on this one. Here's the problem. What's the radius of our circle? They didn't give it to us. Okay, so this is where you guys need to start. The radius is what we need before we can start plugging our numbers in. All right, and what we have here is another right triangle, just to kind of highlight it. There's our right triangle. All right, we have 2 of its side lengths. You need to find this missing side length. All right, which will get, again, will be the radius, and then plug that in as well as the height, and then you can go from there. Okay, so the first thing you guys want to do is go ahead and use your Pythagorean theorem. Plug in the side lengths of this right triangle, solve for r, and then plug those numbers into the volume formula. Okay, give it a try. Okay, so C is the hypotenuse of my triangle, which is a 22. Okay, A and B are the 2 sides. I'm going to make RA, and I'm going to make 20B. Okay, and just like before, I'm going to go ahead and start solving this stuff. So let's see, let's square this. So 22 squared is 484 equals r squared plus 20 squared, which is 400. Okay, solving for r, subtract 400 from both sides. And it looks like we're getting 84 equals r squared. Okay, taking the square root of both sides. So let's see, square root of 84 is 9.16. So I'm going to round that to a 9.2. All right, so there is my radius, 9.2. Okay, now I have everything I need to plug into my volume formula. So let's do it. Volume equals 1/3 pi. The radius we just figured out was 9.2 squared times the height of my cone. Be careful, the height is this line that's at a 90 degree to the base, so 20. Careful not to plug in 22, that's the slant height. All right, and then yeah, let's plug this in. So 9.2 and 20. All right, so 1/3, oops, let me delete this. So 1/3 pi 9.2 squared times the height, which is 20. So I'm getting a 1,772.69. So that 9's going to round the 6 to a 7. So 1772.7. All right, and we're talking about units, so centimeters cubed. Okay, cool. So that is finding the volume of pyramids and cones. Very, very similar to finding the volume of prisms and cylinders. Really, the only difference in this lesson was there was a 1/3 there that we had to worry about. All right, but I just want to point out again, it's all about that capital B and plugging in that correct formula for the area of the base. It's always the thing to keep in mind on these problems. All right, guys, so that's that. I'll see you.